In this video, we're going to practice doing some matching between formulas and surfaces. Here we have our first surface, z equals 2 minus x squared minus y squared, and a selection of graphs to choose from. Take a moment to consider which one you think is the right match, or at least narrowing it down to a couple, and then we'll check in. All right, to start with, what we'd focus on here is that we can write this as 2 minus the unit of x squared plus y squared, and that points to circular symmetry. Whatever shape we have, it has to be circularly symmetric around the z-axis, and so right away that rules out this plane and this plane. We're left with these kinds of shapes. The other strategy we've used before, and it's especially effective when we have circular symmetry, is to pick a value for a variable, and I like x equals 0 because it then leads to a nice relationship in the regular axes of y versus z, and those axes are as close as we can get to the regular x and y axes we used to know and love. They're the in the plane axes, and if we let x equals 0 in this formula here, we're going to get z equals 2 minus y squared. And for graphing y against z, that's going to be a parabola. It's going to open downwards, and it's going to have an intercept at z equals 2. And so if we had that intercept at z equals 2, that would be up here and opening downwards, and then we add the circular symmetry, and all of a sudden we have B being the correct answer. We know it's not D because it doesn't open the right way. We have negative y squared downward parabola, and it can't be this graph either because it's also opening upwards and not downwards. Let's try one a little trickier. Z equals 1 over x squared plus y squared. Take a look at your options and see if you can identify which one that could be. All right, again we have the x squared plus y squared in every shape, so we have the circular symmetry. That immediately rules out that, in fact it rules out everything but these two expressions here. And from here, there are two big options that we can try. One is the same strategy we just tried. If we let x equals 0, then our z is going to be 1 over y squared. And we can certainly sketch that graph. If we do y against z, this is the reciprocal type function, except it has a squared term, so it's actually reciprocal and positive on both sides. If we then add in our x-axis and the circular symmetry, we're going to get shape A for sure. We can go one step further in this case, though, and confirm that the signs of z make sense. If we look at E and A, the two competitors that were left after the circular symmetry, we can see here that the z's are all negative. We're always below the xy axis, whereas if we look at the z's for 1 over x squared plus y squared, these are all positive. And so there's a disconnect there. That graph cannot match the formula we've been given. You'll see in the practice problems a rich array of this matching formulas to graphs. The strategies we're looking at here, looking at the signs of z, looking at the circular symmetries, plugging in values, seeing what happens when x and y are 0 or x and y get large, those will allow you for sure to be able to identify or match formulas to graphs. It just takes a little bit of practice.